Hey guys, welcome to day 17 of the Leetcode challenge. And today's question is search in a rotated sorted array. So you are given a sorted array, but it has been rotated on some pivot, and now you need to binary search a target or a key in this binary sorted array, but it is rotated, right? So you can actually do a two approaches here, right? So the first approach is find the pivot, right? Find where actually the array was rotated, and then do binary search on one of the paths, right? So once you find the pivot here, right, then you can tell that, okay, this is a separate sorted array and this makes a separate sorted array. Now you can compare these two starting L and X and Y with the target key, and depending on where the target lies between L and H or X and Y, you can binary search in one of the two subarrays, right? And the second approach is actually directly search for the key, directly search for the key in a modified algo of binary search, right? So what we'll do is we'll tweak the normal binary search conditions to fit in the rotation, and we'll directly do a binary search. We'll just write one binary search for this. So we'll do the second approach, and we'll not do the first approach in this video. Okay, so let's explore the second approach. I'll rub the board and I'll try to explain the second approach more formally. Okay, now for second approach and for to formulate the conditions for the second approach, we'll look at two examples here. Okay, so first is this example 0, 1, 2, 3, 4, 5, 6, and the second example being 0, 1, 2, 3, 4, 5, 6, right? So if you see, if you take the mid, right? Let's say this is the M, this is the L, and this is the H, right? So usually in binary search, we used to have a target lying in one of the half, either L to M or M to H, right? But now there is also something called the pivot we need to take care of, and we need to find out where the pivot lies. So in this array, the pivot lies here, and this example, the pivot lies here, right? So pivot can also lie here and here, right? So we need to formulate four conditions, right? So which means uh, the target left and right, pivot left and right. This gives 2 into 2, 4 conditions, right? So first of all, let's explore if pivot is on the left side. Okay, when does pivot lies on the left side, which means this particular case, right? So pivot will lie here when the mid actually flips out on the low, right? Because then the mid to high array subarray will be sorted 2 to 5. But pivot on left is equals to when mid is lower than L. This is the flip condition. 2 is less than 6. Right. Now, when this happens, we will bifurcate into two more conditions, right? And find out where the target lies, right? So if target, so we know that M to H in this subarray is sorted, right? So if target is between M and H, right? We know that target lies on right side, right? Target lies on the right side. And what we do is we know target lies on the right side. What we do is L equals to M plus 1, right? And else, if this is not the case, this is the else part, else target is on the left, on left, and we'll do H equals to M minus 1, right? Similarly, we'll define P on right side, okay? I don't have space, so I'll just rub this board here and define P on right side. When this happens, it will happen in example here, right, in this array, right? So the here P is on the right side, here this subarray, right? This happens when M flips on H, which means M is greater than H, right? Or we can, if we define P on left first, then we can also define this as a else condition, right? When this happens, then we know that the left subarray is a sorted array, right? So what we need to find is if L is less than target is less than M, which means target key lies in this subarray which is already sorted. Then target on left, and what we do is we do H equals to M minus 1, right? Otherwise, else what we'll do is L equals to M plus 1, right? And meanwhile, we are doing all this four conditions in the initial beginning, what we just need to check is M is same as target, then return M, right? So let's just code this algorithm and try to see if we can understand it more clearly. Let's just code the algorithm we have just discussed using just one binary search while loop. I'm just doing some sanity check. Here we have to return -1 actually if we don't find any numbers. Right, so let's define L equals to 0, H equals to len of nums -1. Now we'll run binary search from L to H. Let us define M equals to L plus H divided by 2. This is the integer division in Python. We just take low equals to nums of M, right? Mid equals to nums of H, nums of, equals to nums of L, nums of M, high equals to nums of H, right? Don't get confused with LM and H. I was referring to L, M, and H during the diagram to be the actual numbers, not the indexes. Now we need to compare if mid is same as target, then return M, which is the index, right? If now we will list out those four conditions, right? Now if M or low is greater than mid, which means M flipped out, low flipped out on M, which means pivot is on the left side, right? Else here we'll say pivot is on the right side of M in the left subarray or is in left subarray. Okay. Now here we'll check if target actually lies within the sorted right subarray or not, because that is easier to check. So if high mid target is greater than mid and is less than equal to high, then we'll assign low equals to M plus 1, right? Else we can safely assign M H high equals to M minus 1, right? We don't need to define the conditions of the else, right? Because this is easier to do. Now here, if pivot is on the right, then we'll check if target is between the sorted subarray on the left side or not. Is equals to mid. This cannot happen because we already written target equals to mid on the 17th line. Now here, H needs to be assigned M minus 1, and else low needs to be modified to M plus 1, right? Search in left subarray. Here, search in right subarray. Okay, if we cannot find anything, if mid never becomes equals to target, then we can safely return -1 here. Let's run the code on a custom cascade. Okay, expected answer. Let's just submit this. Okay, accepted. Right. You can also do this question by first finding out the pivot and then binary searching on the left or the right subarray given where the target lies. But that is a bit more chunky code, and probably we are not doing this in this video. Probably some later video would explain that. This again runs in order log n. And yeah, thanks for watching this video, guys. Subscribe to our channel for more videos like this. We are doing daily Leetcode challenge that is ongoing, posting our solution, discussing the questions. Like our videos and share the videos if you like it. Thanks again. Bye.